Okay, thanks. I'm aware that I am the person who's gatekeeping everybody from lunch at the moment, so I'll promise I'll try and keep this as short and sweet as possible. Just to give you a little bit of an intro about who I am and what my background is. In my day job, I'm a software developer for the NHS up in Scotland. I'm coming up on about 5 years experience now that I've got working in public sector software development in various roles and companies. That doesn't really have a lot to do with what my involvement is with OpenUK and the open tech space. My involvement kind of came around with a project called Open Data Scotland, which I'm technical lead on, which I'll speak about in a little bit. I'm also a trustee of a charity called Code the City that runs up in Aberdeen. We're a civic society that's all about using tech and open data for civic good. And that's actually where Open Data Scotland came from as well. Also got slight disclaimerish bit that I am not affiliated with GitHub. They've not asked me to come here. They've not paid me to come here. I just think that they're a great platform, particularly with GitHub Actions, and that's why I'm here to speak to you today. So with that out of the way, just to give you a quick idea as to what we're going to run through today is I'm going to go through some key concepts and definitions first, just to bust some jargon and make sure everybody's kind of on the same level as to what we're talking about when it comes to software development pipelines and GitHub Actions. After that, once we're all on the same page, I'll go run through a couple of case studies and then move into a proof of concept that I've come up with myself with the potential of what you could use GitHub Actions for when it comes to data pipelines. And then we'll wrap up with a couple of tips and tricks. And then if we've got time and you're not too keen to go for lunch, then we'll maybe have a Q&A afterwards. So as I said, I'm going to go through some key concepts first. I appreciate that I might be talking to a lot of people that probably already know a lot about this, but just to make sure that everybody's on the same page, I'll go through them anyway. Just bear with me if it's something that's already familiar with you. So the first thing, GitHub in general, what is it? So I stole this statement from GitHub's website. It's the complete developer platform to build, scale, and deliver secure software. So the core part of that is, as I'm sure a lot of people are familiar with, is the Git kind of version control system and the hosting that surrounds that. There's a lot of kind of community-oriented features that come with that for GitHub, for open source projects, with issues and pull requests for contribution, package hosting and management for releases of your software or deploying releases of your software, which then kind of leads you into GitHub Actions as well, which is one of these kind of automation frameworks that you can use. Before I go and explain what GitHub Actions is, I thought it would be useful to go through CI/CD, or as it's also known, continuous integration, continuous deployment. So it's kind of what fits into the main kind of intended everyday use, I would say, for GitHub Actions, is that it's a set of practices and principles that software developers use kind of in modern software development, I would say, these days, where it involves automating your pipeline for development, to automate your building and your testing of your software and your pushing to your integration platforms and eventually deploying to production. And the idea is, through using continuous integration, continuous deployment, is that you provide as much consistency as possible in your software pipeline. So we're not going through the old route of, when somebody adds a feature to an app, then you've got to wait and then pass it on to another team to deploy. The idea is it's DevOps, the pipeline does it for you. And through doing that, you can deploy software in a quicker and more consistent manner without sacrificing any quality or stability. And that's where GitHub Actions comes in, really, is it is an automation and workflow kind of and CI/CD platform that's integrated into GitHub that allows you to do that. If you ever use anything like Jenkins, Circle CI, Azure Pipelines, it's pretty much kind of in the same vein. Although I've just spoken about CI/CD, I think the more important and more kind of interesting part of what you can use GitHub Actions is how you can automate other things with it, particularly when it comes to data pipelines. So just to take you through a couple of the main features of what you can use GitHub Actions for. It runs on most of the mainstream operating systems. So, you can ensure that when you're building things for different platforms, that you can ensure compatibility across the board in the tech ecosystem. There's three main ways you can kind of kickstart your jobs or your workflows when you're working with GitHub Actions. The first being manually, where you could, just go onto your repository page, hit a button, if they've got some options, stick them in, and that'll kick off your job. Or, you could do that through the REST API that they've got as well. So if you're integrating with another platform, you want to kick off, workflows or jobs, you can do that through that. The second way is through scheduling. So you can get jobs to run on kind of a cron-based expression schedule. So if you want to get things running daily, weekly, hourly, even, to pull data or to build your software, you can do that. And then the last one, which kind of is baked into the GitHub ecosystem, is GitHub-based events. So commonly, when you're doing things with CI/CD, you will trigger workflows to run based off of pull requests or people pushing things and merging into master, or even going through to once you've released a bit of software, you can do things out the back of that by generating release notes and stuff like that. One of the great things about the runners is they come with a lot of common developer tools installed out of the box. So if you're working with the likes of Python, Ruby, Node.js, .NET, you don't have to do any installation when you're starting off your jobs in the first place. Generally, it's all kind of in there. And if you're doing a lot of things, if you're doing the same pipeline a lot, and you're finding that you are having to pre-install stuff, you can generate your own Docker-style containers that you can then attach to jobs to use, which means you've got a ready kind of pre-made environment, which saves you a lot of time when you're producing, when you're building and running your jobs. There's also caching features in there that really helps cut down on the time. And if you don't have a developer tool that's pre-installed, there's a great marketplace that's out there. Not just kind of stuff that's been built by the community, but also a lot of vendor stuff. So if you're wanting to, deploy stuff to Azure or AWS, it's got Microsoft and Amazon have built their own kind of tool sets into GitHub Actions, so you can do that. Right through to community projects to do things like post to your Slack channel and post to your Teams channel. So like I said, if you've used a workflow to deploy a release to production, the next thing you might want to do is, if it's an internal app, you might want to actually let people know on a Slack channel or a Teams channel, hey, we've just pushed out a new update and here's all the features that came with it. So it's all kind of really good for integration in that. You might see it's YAML based. No, a lot of developers aren't a big fan of that. It'll put a lot of people off. What I would say is there's a really good web-based editor that's on GitHub's website, which has a lot of prompts and also complete for getting started with workflows, and it'll keep you right when it comes to syntax, because nobody wants to spend ages debugging indentation and arrays and all that sort of things. There's also a lot of template workflows to get you started. So the way that GitHub's quite smart is that it's usually quite good at telling you what code you've got in your repository, whether it's Python, etc. And if you've not used GitHub Actions before, the first time you go into the tab for GitHub Actions, it'll probably say, hey, you've got a Python script here. Do you want to generate a starter workflow, to run that Python script? And it'll go through all the, the basic steps you want to do, like setting up a specific version of Python, installing your packages, running tests, etc. So it's really it's a low barrier to entry, I would say, to get started. Lowering that barrier even more, you'll see in a lot of other services that if you want to run code on their platforms, that you're going to have to stick in your credit card details to start off with, even if it's a free balance. I don't believe that's the case with GitHub, with their free accounts. They actually provide you a run of 2,000 minutes a month on your private repos, and on public repos that you're running, I think it's free usage anyway that doesn't dip into your 2,000 minutes a month. Should caveat that.
Workload's got to be throttled somehow, I would imagine.
Yeah, so I think they stick in a queue based off of other people's workflows and stuff. So if you're finding that you're running a cron job that's every 10 minutes or so, you're going to be sticking in a queue with everybody else that's probably running a cron job every 10 minutes. So it might not be as reliable as you think. What I was going to say is, yeah, you get 2,000 minutes a month, but your usage kind of depends on what operating system you're running on as well. So Linux being the cheapest is like a 1 times multiplier. If you're running on Windows workflows, it's going to be a 2 times multiplier, all the way through to Mac OS, which is unfortunately 10 times as expensive when it comes to using your minutes. But we'll maybe get around. I'll maybe get around to how you can get around that and use some of your own hardware in a bit. I know everybody looks at free stuff and goes, "Oh, that's great. I'll then go start using it to do things that you maybe shouldn't." GitHub does have a terms of service. You can't go start mining crypto or doing any heavy lifting on the platform. So if you're thinking about doing anything about that, don't. So with that out of the way, that brings us into the first case study, which is one that I was heavily involved with, which is Open Data Scotland. And it's an open source, collaborative and volunteer-run project that we use to help people locate and understand open data in Scotland better. So how did we go about doing that? So we keep a weekly census of sorts of all the data sets from open data portals that we're aware of in Scotland. So to do that, it involves building Python script. We have a lot of Python scripts, basically, that pull the data, clean it, process it, put it into a standardized store, and then we publish it to an interactive front end, which incidentally actually uses GitHub pages as well. So it's all kind of within the GitHub ecosystem. And with us doing this, it's all with the aim to help the public understand better how open data is available in Scotland and what you can use with it. So as you saw on the last slide, it's 2,000 data sets. That's a lot for somebody to go and pore over manually on a weekly basis. So when we started the project, we kind of realized quite quickly that there was going to have to be a lot of automation to keep this sustainable. We did this manually over a weekend with about 5 people at a hackathon, and we managed 427 data sets, which is in a Google sheet, and a lot of that was still manual lifting without automation. So after we did that and we met up at an X-hackathon, we built the project with sustainability in mind, with a lot of automation through scripts and Python, through to also then taking GitHub Actions as the automation framework around that. We kind of learned very quickly when we were still manually pulling the data sets that a lot of our contributors that were involved in that on the weekly basis for a weekly task use different environments and operating systems. I run on Windows. One of my co-maintainers runs on a Mac. You get into a whole load of compatibility issues when it comes to that. So using GitHub Actions and running in a Linux environment kind of ensured that we had consistency across the board when we were pulling that together. And it meant that we could run it on a weekly basis and kind of just set and forget about it, to be honest. And one of the great things about this is that we're able to kind of cascade workflows together. So we've got an initial scraping task that will grab all the data and commit it to our repository as an archive. But then as soon as that commits, that'll then trigger another job to actually republish our site and refresh the data sets that are on there. So it just kind of shows how you can use those different workflows you've got as puzzle pieces to pass data in between. So you could either do that through the likes of committing data to repos through to artifacts, or if you've got a REST API that you want to push data through, you could do that. It's really reliable as well. So this pipeline that we've got has run for nearly 2 years. I checked the stats last year just to see how well we performed. Our pipeline only failed 6 out of the 52 weeks last year, which for a volunteer project, I would say a 12% kind of failure rate is not bad. I'd also say that, the failures that we had were down to our bad code. It wasn't down to GitHub Actions. It's been super reliable. It runs on a weekly basis without fail. And speaking of failures and uptime, GitHub Actions actually allows us to then track the failure and uptime of open data portals that are out there. So we do a daily uptime check about 8 o'clock each day. We will go and ping all the websites that are out there and check if they're still alive, because we don't want to host, or point to open data sets that are out there if they're not going to be available. So if we find that a portal's down, we'll actually use GitHub Actions to open a GitHub issue in our own repository. That'll also then link into our Slack to let us know and let the community know that, hey, this open data portal's down at the moment. If you're looking for this data, it may not actually be available. And we'll find sometimes that we actually find out about the downtime before the owners of those data portals know about it themselves. Some of them are in our community, so when we just give them a ping on Slack and say, hey, what's going on with your data portal? Some of them will have to send an email and be like, what's going on? But then we use that kind of community that we've got within Slack to triage that and keep track of that and keep the community aware of what we're going on. It's quite transparent because we want to know what's happening with that data if it's disappeared. I don't really want to go too much detail, though, about Open Data Scotland. I spoke about that last year, and so did my co-maintainer, Karen. The recordings for that talk are uploaded onto the OpenUK YouTube channel, as I believe the talks from this conference are going to be as well. I've stuck a link at the bottom of the slide. Don't worry too much about taking note of it just now. I have just, I believe, uploaded these slides onto Sked this morning, so you should be able to grab it later if you want to have a look at those. That takes us into our next case study, which I discovered actually when I was at the Scottish Open Data Conference up in Aberdeen last year. And I was made aware of some of the really good work that was going on with the DC Thompson data journalism team that's there. They're based in Dundee, and there's only actually 3 of them. So some of the work that they've managed to do is actually remarkable, considering they're got such a small team and not a lot of resource. And they were showing me there how they were able to take some of the open data that was published by Public Health Scotland and transform it into trackers to show trends over time in various bits of NHS data, whether it was waiting times when it comes to diagnostic operations, through to which times in A&E are the most busiest in different health boards in Scotland. So the way they do this, I thought it would be handy not to show some scary YAML, but to show some actual outlines of what comes from that YAML. So that gives you your sort of basic outline as to how these jobs work. DC Thompson's jobs are a pretty good example of a clean structure as to how you do this. So you usually end up with a setup kind of stage to start off with. So although you maybe have a lot of tooling that's already installed, you're still maybe going to have to do things like pull down your repo or pull down repositories if you've got various scripts in various places, install any dependencies or packages, commonly if you're working with Python, stuff like pandas. And then you get into the kind of, the meat of it, of actually running your scripts and going out and pooling your data, transforming it if you need to, writing it where it's going, and then you move on to the publishing stage, the green phase down the bottom there, where you're going to take that data that you've written, save it somewhere, whether it's a repository, an artifact, and then pass it on elsewhere, whether it's going to be to publish to a website or sit in a repository to be consumed by other things. And I learned from them as well that one of the great advantages was that they didn't really know how to get started with this. So I think they actually based their workflow off of workflows that were done by The Economist when they were tracking COVID excess deaths during the pandemic. So it just kind of shows one of the values of open source that, if you're not sure where to get started, have a poke around someone else's repository, go and have a look at what they're doing. If you see a project and you wonder how how did they do that? If it's open source, you can probably go in there and see how it's being published. And they end up with a kind of end result that looks something like this on their website. And that's just, I think that's just consumed directly from the repositories to build these visualizations to show specific trends over time. So we see on the one on the right, that was a massive dip that was during COVID on waiting times. I think the busiest time in A&E one's really handy as well. And not only are they useful for the general public as well for these sort of visualizations, but I think it's a really important kind of repository that they can then use internally for stories that other journalists want to work on. If journalists are contacting the data journalist team and saying, I need data for a specific thing, they've kind of got it ready-made and ready to go, in a maybe a more kind of clean format compared to what's published by some other open data providers out there. And that's kind of the end of that example. So it got me thinking, how could I kind of spark interest maybe a bit more, show what is the point as to what you could do with this stuff. So I came up with a practical example of how you can take data that you've maybe got on premise that's not easily accessible to the internet and actually publish it on a GitHub repository. One of the great things about this is that you can use self-hosted runners. So, if you're going to find that you're using more than 2,000 minutes a month, if you want to publish regularly, you can actually use your own infrastructure and your own hardware, either on-prem or within your own kind of private cloud, to pool data and resources within there, whilst also then only using your own resources. So you're not charged for using self-hosted runners other than, the electricity that you have to pay in-house or whatever, the resources to run that. So that's really good if you know that you're going to go over your 2,000, minutes, or if you want more control over your hardware that you're using. So I came up with a really kind of rudimentary example. For argument's sake, the on-premise environment for this is my house. I've got a temperature sensor that's in my house. It tells me how hot or cold my office is. It logs it to a database. I'm then using a Raspberry Pi to access that database and pull the data. The Raspberry Pi is running the self-hosted runner. So, you don't have to actually spin up like a big server or anything like that on premise to run these. They will run on Raspberry Pis. They run on ARM architecture as well as, Windows, Mac, Linux. So it's not difficult to set one of these up. When you set it up and kind of instantiate your runner, you've got a little script that you download and, set it up and associates it with your repository, your organization. It's not difficult to do. Security-wise as well, it's pretty great because you don't actually have to do anything like port forwarding or any external access for your runners. The way the runners work, I believe, is they pull out to GitHub on a regular basis to actually ask for jobs to then run. So it's totally secure and peace of mind. You don't really have to worry as much, unless somebody has access to your GitHub repository. It's not going to be very easy for them to actually get code running on your self-hosted runner. So in this case, the Raspberry Pi is running a job on a scheduled basis, which will then pull the data from my database and commit it to GitHub Actions. And similar to what we've got with Open Data Scotland, that commit will then trigger another job that then builds a website, which I've done a really horrible data visualization here in D3.js. People out here that do better data visualizations will be tearing their hair out at the standard of that graph, so I apologize. This is just a basic example of what you could visualize with that data. So my script just builds a CSV that you can then use to generate a graph like that. But, kind of the idea is that data can go anywhere at the end. You could take it and, it could even get consumed by the likes of Power BI, Tableau, or you can pass it on elsewhere, or just have it in your GitHub repository if you're wanting to host it and make it accessible to people. So that takes us towards the end. So if I'd finish up with a couple of tips and tricks just to take away if you're wanting to get started with GitHub Actions. Number one, watch your usage. You've only got 2,000 minutes a month. Depending on what hardware you're using, you've got even less, really. Keep an eye on how long your jobs run for, especially when you're testing. You don't want to end up with something that's recursive or runs in a loop that you then set to run overnight. You come in the morning and you've used all your usage for the month. It's not great. I've done it. So, there's ways of getting around that by looking after your jobs or, making sure that things are running on a test basis. Number two, containerize for consistency as well. Spoke about that earlier. One of the most important things is consistency across your environments and making sure that things are running in a reliable manner. You can do that through containerizing, and it means that you've got a ready-made environment with little to no setup that's actually required after you've set it up. Keeping secrets safe as well. We kind of want to keep things in the open, with open source, but at the same time, if you're accessing APIs, you don't really want to have your keys saved to your repository, whether that is public or private. It's important for both to make sure even that, if your repos get compromised, your secrets don't go with it. GitHub Actions has a secret management kind of interface built in to make sure that you can just save your secrets once and nobody's going to have access to them again once they're in there other than what's in your jobs. And it's not going to show up in your logs either, so you're saving yourself any embarrassment there. And the last one that we kind of just touched on with that practical example is saving with self-hosted as well. You need better control over your software or hardware that you need as part of your jobs. If you need access to on-prem environments, self-hosted is a way to go, to get access to that, but also to save money in the end as well if you've got spare hardware that's kicking about that you can use, whether it's from a Raspberry Pi through to a full-blown server. And that takes me to the end. So all the resources that were in the talk, I've got in a slide at the end that's in the slide pack. So if you're wanting any access to that, I would say go check that out on the conference website. And do we have any time for any quick questions, Sonia?